Hi, this is going to be lesson 4.3. We're going to be talking about proportional relationships and graphs. So let's begin. Okay, so our standards are going to be I can identify proportional relationships from graphs, I can graph proportional relationships, and I can analyze graphs. Our standard is going to still be RP2, recognize and represent proportional relationships between quantities. Minimize myself, and we will begin. Okay, rates of change are everywhere. Okay, you've got to love rates of change. Not that bad. Okay, this is the same thing here. Just a review of the slide that we had the previous two videos ago. Again, recall that a rate is a ratio in which the two terms are in different units. For example, miles and hours, right? Those are different units. A rate of change is a rate that describes how one quantity changes in relation to another quantity. Rates of change can be constant. We learned about that last time, or variable. They can change. We didn't see any real examples of that, but you probably did in your homework. Recall that a proportion is a statement that two rates are equivalent or equal. So 60 miles over 1 hour is equal to 120 miles over 2 hours. And finally, a proportional relationship between two quantities is one in which the rate of change is constant, or the ratio of one quantity to another is constant. That was just a review. So let's talk a little bit more here about using proportions to find table values. Most shower heads that were manufactured before 1994 use 5 gallons of water per minute. Is the relationship between the number of gallons of water and the number of minutes a proportional relationship? Okay, so let's take a look at our table. We're going to have to fill it in. So we have time being the independent variable, the x variable. Time never depends on anything else. It just keeps happening. It's always independent. The dependent variable is gallons. The amount of water used depends on how much time has gone by. So let's see if we can get the numbers in there. So there is our rate, 5 over 1. Remember, the unit rate is where the bottom number is a 1. So it's always y divided by x. Let me get my annotate here. So y divided by x is 5 over 1. So the unit rate is where the bottom number is 1. So the unit rate happens to be 5. 5 gallons per minute. So let's clear here. So we're going to use that rate, 5 gallons per 1 minute, and we're going to fill in the table. So 5 gallons over 1 minute equals, remember gallons have to stay on top with the other gallons. Minutes stay on the bottom with minutes. So now we're going to 2 minutes here. We're going to figure out what y is at 2 minutes. How many gallons have been used? Cross multiply 5 times 2 and divide by the number that's left. And the number that we have left is a 1. Okay, so we're going to divide by the 1. So if we do that, we get 10. So we can fill the 10 in our table there. So if 2 minutes have gone by, 10 gallons are used. Okay, let's do it again. Put 5 gallons per 1 minute and then y over 3 seconds. Cross multiply 5 times 3 divided by 1. 15 gallons. There you are. Now the next one, notice how we're missing the time. So we have to set our proportion up a little bit differently. Different thing missing. X is missing this time. So X is on the bottom. The minutes is missing. So when we cross multiply, this time we're cross multiplying these two diagonally. So it's 35 times 1 divided by, divided by 5. So 35 times 1 divided by 5 is 7 minutes. That's going to go up there. And finally, the last one, 5 gallons per 1 minute is equal to how many gallons for 10 minutes? Cross multiply and divide. 5 times 10 divided by 1 is 50 gallons. So now that we have our table, we can decide if the relationship is proportional or not. So let's go on to the next page. We're going to pull up that table again that we just filled out. There are the numbers we just figured out. Is the relationship between the number of gallons of water and the number of minutes proportional? That's the part we're going to figure out now. There's our rate again. A proportional relationship, remember, is between two quantities when one in which the rate of the change is constant, or the ratio of one quantity to the other is constant. Y over X has to be constant. Yes, the number of gallons per minute is always 5. How do I know that? Well, I have no room here, but 5 divided by 1 is 5. 10 divided by 2 is 5. 15 divided by 3 is 5. 35 divided by 7, y over x, right, is 5. And then finally 50 divided by 10 is also 5. So every time it's 5. So that's constant, 5 gallons per minute. Now we want to graph the proportional relationship. This is the same chart that we filled out before, and now we're going to graph it. So let's figure out how do we graph the data. So when we graph data on a coordinate plane, X is your first coordinate and Y is your second coordinate. For those of you who worked last spring, we did some of this plotting and stuff. So let's clear my little arrows there. So we are going to put our X and our Y on our graph. So I've made a graph here for us. Time X is always on the horizontal. Y is always on the vertical. And then we have to figure out what scale we need. Well, this goes up to 10. So I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each line is 1 unit. And notice how the numbers are on the lines, not by the spaces, because you want them on the lines. Otherwise, it messes everything up. And then the water used, I have to get up to 50 because that's the biggest number I have in my table. And my smallest number is 5. So I went up by 5s. Well, I kind of went up by 2.5s because every line is 2.5, then 5, then another line, it'll be 7.5, and then 10, and then another 2.5, and then 15, 20. So every other line is 5. Okay. So X is my horizontal, Y is my vertical. So my first point is 1 and 5. So X is 1, 5 is the Y value. So notice how I find 1. It's not labeled as a 1, but you can tell because it's next to the 2. It's the line before the 2, it's 1. 1, and then I go up the number of the Y value. I went up to 5. So I find the line 1, and I go up to 5, and I put my dot there. So that's point 1, comma 5. Always put that comma in between. Let's plot 210. The next one in our table. So we find the number 2 here, and we go up to 10, and we put our dot. So there's 210. Now we're going to plot 315. So we go out, find the number 3, and we go up to 15, and we put a dot there. And we put 315 there. Then we do 735. So we find 7, which is, let me just get my spotlight, see it better probably. Here's 7, and I go up to 35, and I'm going to put my dot right there, where my red mark is. So let's put our dot, and that's 735. And one more point, 1050. So I'm going to find 10 on my X value and rise all the way up to 50 and put my dot right there. 1050. There we are. And now the fun part, I get to connect the dots. Yay! There we are, connecting the dots. That is the graph of our proportional relationship of time to gallons used. Using the graph, how many gallons will be used after 8 minutes? We can do this without setting up our cross multiply and divide proportion. Did you know that? Once we have a graph, we can just use our graph. So we find 8 minutes right there on the bottom where the circle is, and we rise until we hit the graph. So I rise at the 8, I hit the graph right here, and then I go over to see where I landed. So what's the y value at this point? Well, it's 40. That means that I have used 40 gallons after 8 minutes of time. So it's really easy when you do that. If you have the graph, you just find the number you're looking for, rise until you hit the graph, and then go on over to see what the y value is. Testing for proportional relationships with tables. A house cleaning company charges $45 per hour. Is the relationship a proportional relationship? Well, we made a table. So for 1 hour, remember, time is always independent. The cost will depend on the time, so that's dependent. $45 for 1 hour. For 2 hours, it's going to be $90. For 3 hours, it's going to be $135. So I could just multiply 1 times 45, 2 times 45, 3 times 45, which is exactly what I'm doing when I'm setting up a proportion. So if I have 45 cost and then 1 hour, and I want to know how much it costs for 2 hours, I'm doing this, right? And then I'm cross multiplying 45 times 2, and I'm dividing by 1. So the 1 is kind of irrelevant in the situation, so 45 times 2 gives me 90. 45 times 3 gives me 135. So you can set it up either way. So that's kind of what I'm showing you here. Now we're checking for constant and proportionality. So 45 over 1 equals 45. Does 90 over 2 equal 45? Yes, it does. Does 135 over 3 equal 45? Yes, it does. Does 225 divided by 5? Put that on your calculator. What do you get? 45. And what about 360 divided by 8? 45. A table is proportional if the ratio of y divided by x is constant. 45 every time. Y over x is equal to 45. That is the rate. The rate is $45 per 1 hour. That's our unit rate. Testing for proportional relationships with graphs. The last one we tested for was with a table. Now we're testing for proportionality with a graph. We have the same table. This time we're going to make a graph out of it. X comma y. So notice how I have time on the bottom. Each line counts as 1 unit, and then going up, I had to go up, well, I went all the way up to 720, but I technically only had to go up to 360 because that's how far my table goes, but that's okay. So we're going to plot. There's your x values. That gets plotted first, then your y values get plotted second. So the first point we're going to plot is 1 comma 45. So we're going to take our red spotlight here. We're going to start at 1. And we're going to rise up to 45, and our dot's going to go right where that little red mark is. So let's pop it in there. And that's 0.1 comma 45. Okay, the next point is 290. So we're going to find the 2, and we're going to rise up to 90. Our dot's going to go right there. There it is, and that's 2 comma 90. We do the same with 3 comma 135. There's 3, 135. Should be on the line. It's a little shifted. It should be right on the line there. And the next point is 5, 225. That one's shifted a little from the line too. And then the last one is 8, 360. There it is. And then the fun part, connect the dots. And there is our graph. Now, a graph is proportional. Remember, this is testing for proportionality using the graph instead of the table. A graph is proportional if it goes through the point 0, 0. 0, 0 is always the corner starting point here, isn't it? So does that graph hit the 0, 0? Yes, it does. Why does it hit the 0, 0? Well, if no time has gone by, you have no cost, right? No time goes by, no cost. Okay, so, oh, now it's your turn to give the question a try. Okay, welcome back. This is just a review of the last slide there, the constant proportionality. Remember what that was? That's K, right? That represents the rate of change or constant ratio between Y and X, or X and Y. In order to have a constant of proportionality, the relationship must be proportional. There's your formula. K equals Y divided by X. And then you can rearrange it to be Y equals KX. That's the equation form. That was just a review. You could go back and watch 4.2 if you need a better review. So let's continue to review just another slide here. Remember that K represents a constant rate of change or constant ratio between two different units called X and Y that have a proportional relationship. So if you remember right, we had done this one. 2 pounds of cashews had costed us $10, 3 pounds had cost us $15, and 8 had cost us $40. We figured it, we wrote a table for that. We found K using the formula. We set it all up every time. We found the constant of proportionality to be 5. So then we wrote an equation. We had Y equals KX, and we put 5 in for the equation. Y equals 5X. That's just a review from 4.2. How much does it cost for each pound of cashews you buy? It costs $5. So knowing that review, let's go on. Analyzing graphs with a constant of proportionality. This table can be represented by a graph, the ones with the cashews. We didn't do the graph on the last lesson. We're going to do the graph on this lesson. So I have pounds on the bottom. That's my independent variable. And I have my dependent variable, my cost, on the y-axis. And then I'm going to plot my points. So 210, 315, and 840. And then I'm going to connect my dots. There's my graph of this table and this relationship. The steepness of a graph is K, the constant of proportionality. In a proportional relationship, K is also called the slope. There's our formula, Y divided by X. So in our case, 10 divided by 2 equals the same as 15 divided by 3, which equals the same as 40 divided by 8, which equals 5. That's our K, our constant of proportionality. This graph has a steepness of 5. Y equals KX is our equation. We're just going to plug the 5 in for K, and there's our equation of our line. Y equals 5X. For a school field trip, remember this one from the last lesson? There's 1 adult to accompany 12 students, 3 adults to accompany 36, and 5 adults to accompany 60 students. Write an equation. So we made a table based on the numbers in the problem, and then we found K, 1 over 12, 1/12, 3 over 36, 1/12 if you reduce it, and 5 over 60, 1/12 if you reduce it. So the constant of proportionality, K, is 1/12. Then we write an equation. So we have Y equals KX, and we put in 1/12 for K. That's the equation of our relationship. What is the ratio of adults to students? 1 adult for every 12 students, right? There it is. So this last one, we had plugged in 84. students, and we decided there'd be a 7 adults, right, when we plugged it into the equation. So that's just kind of a review. So let's talk a little bit more about K. Graphs can be uphill and are represented by a positive K. Now K is only, the slope is only called K when you have a proportional relationship, okay? If you don't have a proportional relationship, you can't call it K anymore, you have to call it slope. We'll talk more about slope coming up. But an uphill, a positive K is an uphill slope. And you always start from the left and you go to the right. So from left to right, this hill is going up, right? Graphs with a downhill are represented by a negative K. There's a downhill. You start at the left and you go to the right. The steepness of the uphill or the downhill is called slope, and the steepness is given a number called K. So we have 3 different steepnesses here. Which one do you think is the most steep? A, B, or C? Right, A. That would be the least hill that I would want to bike up. Which hill would I prefer to bike up? Well, C would be my first choice because it is the least steep. So A is the steepest because it is the hardest to bike up. Which line is the least steep? Well, we decided C because that is the easiest to bike up. So it's given a value. So your steepness of your graph, your line, is given a value called K, or later called slope. All about slope. Let's take a look. Which line would be given the largest K for its slope? A, B, or C? Right, A, right? A would be the highest number because it has the steepest slope. Let's give it a 5. Which line would be given the smallest K for its slope? Exactly, C, right? Line C would have the lowest number because it has the least steep slope. So we'll give it a number of, let's say, 1. And what about B? What number do you think we could give B? Well, something less than 5 but greater than 1, right? Line B would have the number somewhere between A and C, so let's give it the number 3. So you see how the numbers relate to the steepness of the graph. Analyzing graphs with a constant of proportionality. The graph shows the relationship between time in minutes and the number of miles Damon runs. Write an equation for this relationship by finding K. So I don't know why I don't have a table for you, but these are the points on his graph. And there is his graph, okay? So what does 10:1 mean? So after 10 minutes, he's gone 1 mile. After 20 minutes, he's gone 2 miles. After 30 minutes, he's gone 3 miles with his running. So we're going to find K, Y divided by X. So Y in this case is 1. K is 10, time, X is 10. And 2 over 20 is also equal to 3 over 30, which if you reduce those all down, they are 1 over 10. So 1/10. So for every 10 minutes, he goes 1 mile. So this graph has a steepness of 1/10. Not very steep, is it? But it looks kind of steep. Y equals kx. We're going to stick 1/10 in for k in our equation. And we've got y equals 1/10 x. What does the point 30, 3 represent on the graph? What does that represent in terms of our word problem? Well, that in 30 minutes, Damon can ride 3 miles, or run, I'm saying, run 3 miles. After 30 minutes, Damon runs 3 miles. Okay, your turn. See you back in a moment. Okay, welcome back. Now we're going to focus on some higher order thinking. If you know that a relationship is proportional and you're given the point 2, 6, how can you find another pair on the graph, another point, right? Another point on the graph. 2, 6 is the one you've got. Well, step 1, The key word is proportional. Since you know the relationship is proportional, you can find k as y divided by x. So 6 divided by 2, that's the point we're given, is equal to 3. So write the equation for the graph using k. Y equals 3x. Now we can choose a value for x. We can pick it out of whatever number in our imagination we want to use. I probably wouldn't pick 2,434,000 because that's a very big number. I would probably choose a smaller number that's easy to calculate. And then I would solve for y. So what I'm going to end up doing is plugging my number that I choose in for x and multiplying it by 3. And that will give me my value for y. So what number am I going to choose? I'm going to pick 4. So we're going to put 4 in for x. So instead of x now, it's 3 times 4. So what's 3 times 4? 12. So y equals 12 when x equals 4. So our point is 4, 12, and that's a point on our graph. Okay, you get to try one of these type. See you back in a minute. Okay, we are finished with our lesson. Your assignment is on Google Classroom, and I hope that you have a good day. Bye.